Okay, this is about section 8.3, open sentences and their graphs. So what we want to do is first understand what an open sentence is. It's an expression that has a variable in it. The solution set is the set that contains things that make that expression true. A replacement set, we'll do those in the next example video, but a replacement set are going to be restricted input values for the expression. For this particular test, we're only going to be dealing with number line graphs. In the next test, we'll deal with coordinate plane graphs. Remember your sets of integers, and I've told you your different sets of numbers. Real numbers, that's everything. Fractions, decimals, positives, negatives, zero. Integers, they're positive, negative, and zero, but no fractions or decimals. Whole numbers, notice the zero is in the number, so zero and the positive whole numbers only. No decimals, no fractions, no negatives. And natural numbers is the set of counting numbers, so that starts at 1. So no zero, no fraction, no decimal, and no negatives. Alright, for every problem you're going to start the same. We're going to begin by solving the equation. And I've just picked easy equations for the lesson, but your equations on your test could be any type of equation. So we'll subtract 15. Yep, my pen didn't want to write. There we go. That cancels, and I get x equals 9 minus 15 is negative 6. Okay, so now we want to solve this over the set of whole numbers. Well, the only possible answer for the solution is the value x equals negative 6. So is negative 6 in the set of whole numbers? Well, no, because remember, whole numbers is 0 and positive whole numbers. So there would be no solution if we asked for this answer over the set of whole numbers, because negative 6 is not a whole number. Now, if we changed that to say, well, solve it over the set of integers, integers does include negative numbers, so your answer or your solution set is just the set including the number negative 6 and only negative 6. Okay, the next problem. This is an inequality. It has a greater than or equal to symbol in it, so that makes it an inequality, which means we're going to have more than just one number as an answer. First thing you do is you solve it as if that were an equal sign. That means get rid of the minus 4 by adding 4 to both sides. So I have x greater than or equal to 9. Well, that's the solution, but we're solving over the set of integers, so I need to graph it on a number line. Put the number in question here, 9, in the middle, and then give me 3 numbers to the left of 9, 3 numbers to the right of 9. That works for most graphs, not all, but most. So my next number less than 9 is 8, then 7, then 6. Numbers greater than 9 would be 10, 11, and 12. Now for the set of integers, remember we don't want the decimals and fractions that are between 9 and 10. All I want are the whole numbers, positive, negative, or 0. So what are the numbers? What is the first integer that is greater than or equal to 9? Well, 9's an integer, so that could be the first answer. What's the next one? Well, it'd be 10, and then 11, and then 12, and you'll notice that we could keep going and going, so I'm going to darken the arrow as well to indicate that it keeps going and going. So now here's my solution. Here's my number line graph. And for integers and natural numbers and whole numbers, you need a solution set. Okay, that means set notation. So convert your graph here to set notation. So my first number is 9, then 10, then 11, then 12. And how do we indicate keep going and going in a set? You put dot, dot, dot. And that says all the numbers 9, 10, 11, 12 keep following that pattern and keep going and going to infinity. Okay, let's do an example of a natural number. So we're going to take the problem and solve it first. That's the first step for all of these, so get rid of the plus 3 by subtracting 3. This is going to give you x less than 2. So that's my solution. Now for natural numbers, integers, and whole numbers, we'll draw a number line. The number in question in the middle, that's 2. 3 numbers to the left, 3 numbers to the right, smaller numbers to the left, larger numbers to the right. Okay, and now I want to graph this. So what is the first natural number less than 2? Well, it wouldn't be 2 because 2 is not less than 2. It's equal to 2. So the first one would be 1. What's the next natural number? Well, the next number would be 0, and 0 is not a natural number, so the only answer for this problem is 1, based on the set of natural numbers. So the solution set would just contain the set 1. Okay, one last example for this video. So we have x plus 2 less than 3. We'll subtract the 2. X is less than 1. Nothing different here, just simple solving it. Now we want to draw the number line. Put 1 in the center, 3 numbers to the left, 3 numbers to the right. Numbers less than 1, numbers greater than 1. Okay, what is the first integer less than 1? Well, again, it wouldn't include 1 because 1 isn't less than 1, it's equal to 1. So the first integer would be 0. What's the next integer? Well, integers do include negatives, so we'll keep going. -1, and then -2, and then it keeps going and going and going. So we darken that arrow. And now remember, we're going to convert this into our solution set. Anytime you see a darkened arrow, you put ... This time, my ... comes first, followed by -2, -1, 0. Your solution set should always be from smallest to largest, so it just automatically translates from your number line graph. And you're done.